Okay, this is the Ripple Radio and the Earthquaker speaking, bringing you this broadcast. So what you're looking at is an engine, but we're mostly going to be talking about a circuit. Circuits are copyrighted. We'll talk about the flow of circuit and energy momentarily. First, we have to understand that gas, liquid, electricity all flow in the same principles of electronics, of engineering, and electronics. But also so does sound. But gravity, light, electromagnetic waves all go the same speed, 186,000 miles per second. But sound is relatively slow. What we're going to be showing is that we can bring sound up to that speed as well and use sound as thrust. Okay? So gravity gets pulled in here. Comes to the bow tie of superconductivity, gets accelerated, attenuated. These two come together. I'm just showing you just a basic artist rendition. It's easier for me to make models than it is for me to make CAD drawings. I do CAD drawings after the fact because they take me quite a bit of time. I'm not that proficient. I'm okay. So let's go over that again. Gravity, so that we can point to a planet and pull our way to it. Come through the bow tie of superconductivity, up-click that gravity. Here's our hydrogen deuteride burner and our hydride fuel, pure E, that's produced on board. We'll see that in a moment. Just hang tight. This is our Z pinch. We got 33 clicks up and 33 clicks down. We figured out that the electron, not just positive and negative, it can go positive and negative 33 up and 33 down, along with hydrogen. This is the representation of the exhaust, or the Cat's Eye Nebula, or my avatar, courtesy of NASA, of my H Hydrogen for Power YouTube channel. Okay, let's talk about aerodynamics really quick. Let's look at it a little differently. We all understand the boundary layers of aerodynamics. That's fine. We understand lift. But just think about it a little differently. As the dielectric of the air comes to the brunt of the wing, it's automatically put to its ground state. Then as the lift happens, as the air spreads, the dielectric spreads. But the bottom half of the wing is flat and the top half of the wing is curved. But they're the same. All it's doing is spreading the frequency of the air, which lessens the density upon gravity, lessens the density upon the magnetic lines of flux, gives us our lift. Just have to look at it a little differently when you understand gravity and lift and repulsion. Okay? I said that correctly. Lift and repulsion. They're different. Gravity pulls down. It doesn't push you down. It pushes you down. It doesn't pull you down. A little bit different. Okay? So now let's just go over some quick numbers because data is sound. Gravity is sound. So here's where we're at. Okay? 2 is a megabyte. I'll show you the screen and the calculation so you can do it yourself. 2 times 4. Okay? There's the gigabyte. Times 8 equals the 64-bit processor. Times 4 equals the 256 Pentium. Times 2 equals the 512 Pentium derated. okay, times, now we understand that the magnetic moment from the toroidal coil computers to the chip, we can go 0 or 1. Okay, so the best that we can do is times 2 equals, there's their terabyte. Okay, now we have to stay there for a while because we're still at a 0 or a 1, a positive or a negative. Now they figured out that we can put an electron in a pocket under a supercomputing. So we can go positive and negative, a 0 or a 1. It just means taking the electron and going a positron or a negatron. Okay? So you have to times that times 4. Roughly. It'll be derated to about 420, but we'll stay at 4,000. That's a pretty fast computer. Okay? That's a very fast computer. But that's not where we're at. Where we're at in proton spin technology is here, because we have to go times 33, because we can up-click 33 or down-click 33, the electron or hydrogen. The pH scale goes to 33 for a reason. There's 33 strains of bacteria, cyanobacteria, for a reason, because it's hermeneutically correct. Equals, that's coming in the door. We can count that on the oscilloscope coming in the door. But we have to go times 4 equals, that's where our speed is. That's why the electricity is so fast. That's why we can produce so much energy and so much density. And I've been teasing you, showing you the energy going from ground state up into a plasma on the oscilloscope. That's running on its own power. And we're going to show that one more time, running on its own power in a couple of minutes. Just hang with me. Okay? But we got one more step, because we have to go times 6 equals this times 3.14 equals this divided by 2. The reason we divided by 2, because we're using 6. We're using graphene in the pocket of where the carbon used to be. So you've got 6 electrons in that pocket, but you divide phi in half because it's flat. So you just take the rough ratio of half, equals, that's where we're at in speed. That's the frequency divided by, watch this, divided by 2 equals roughly 26.4 terahertz. That's where we're at in energy density. Ladies and gentlemen, when you can switch under load at 26.4 terahertz, that says 25, but it's not calculating the ground state of the oscillator, which gives us the 26. We can count that on the oscilloscope. When you can get there and switch under load, we can have a discussion. This is an education for you of where we are and why we can go so fast, and why you see those oscilloscope shots that you guys have been seeing during the intermission. I had to slow motion those down on my phone so that you can actually see how fast the energy is. You cannot see it on the oscilloscope. Okay? So let's take a look at something wicked. This way something comes. Pardon my mess, I've actually been working a little bit. So we hide nothing. Okay, this is the oscilloscope. This is my patterns. Okay, the power supply is disconnected. The power is off. It's only the oscilloscope. There's nothing on. I want you to watch this. This is the scope lead touched here. And there's my wave pattern. Because the circuit is running on its own power. It's imposing the vibration into this surface from here. Okay, I'm off, I'm on. What you're looking at here is heavy hydrogen fuel for our thruster. This is not pure E. This is something different. This is heavy hydrogen, okay? The pH is 33 down here. The water is 26 pH, the same as our frequency. This is our oil in a one-step process, in the Bloomy process of making saltwater fuel oils. I want you to see how thick that is. You see the consistency there? Look at the oil on top. Okay? We're going to unlock the explosion videos and the burn videos of this oil very shortly. They've been done many years ago. There's no need for me to repeat them. Okay? I can guarantee you this is not my electrode. All of this mass and all of this mass did not come out of these two electrodes. I guarantee that. Okay? Here we are. This is our thruster. Coming through the bow tie of superconductivity. Down here into our gravity thruster. And we're just going to see. Here's our vacuum gauge. And this is the size wire that we'll be using to perform our plasma. Right here. That's it. That's all we need. And this, all I have to do is just touch it here. I don't even have to make a connection. But we'll make a basic connection just so I don't have to hold it there. The wire comes right over here and it comes over to this manifold. Okay? So if you want to see the power of the fuel, I'll hook up the oscilloscope. Okay, it's triggered. That's how fast it is. Back to our system. This is a copyrighted circuit. What you just saw, the engine, that's a circuit. This is copyrighted circuit. It's much more powerful than a patent. So I'm going to go ahead and explain the circuit. This is our fuel reformer. You've seen the hot electrode videos. This is going to perform fuel. The pure E fuel is white. We're going to build a little bit of pressure. We can go up to 6,000 psi, but we're just going to hang out at 30 psi. More than plenty enough. This orange tube is a fuel line. It's a safety valve here. That's a pressure regulator. So once it's set, it should be just fine. This is a very fine needle valve, so we can adjust the flow. This valve, I can turn down, make some bubbles, fill a balloon, whatever I want, do some gas tests, run it through the spectrometer, whatever I want. We use a different kind of a spectrometer here. Or I can come up through here into the chamber. This is a quick disconnect. Okay, as soon as I disconnect, it seals the chamber, and this is open to atmosphere. This is just held together, okay, for vacuum and for safety purposes. So in case it pops, we just have a stop, not a catastrophe. We are going to add some components to this so that we can add pressure to this chamber, because contrary to popular belief, fusion is not performed in a vacuum. It's performed under an immense amount of gravity pressure, not atmospheric pressure. There's a little bit of a difference, quite a bit of a difference actually. The sun does not work in a vacuum. It produces the vacuum on the same principles that a diffusion pump works. The hot oil is heated up, and as it's cooled down the sides, it creates a vacuum. Okay? The same kind of principles. There's an argument. And that argument is, what temperature is actually the inside of the sun? If you see me holding my red hot electrodes, you would have to possibly come to the conclusion that the sun is cold inside. Well, why would I say something crazy like that? Let me explain why. Where did the sun come from? It had to come from hydrogen, a ball of compressed hydrogen metal. You're looking at hydrogen metal in an isotope, okay? That is hydrogen metal. Whether you like to hear that or not, that's what that is. It's a component of my hydride fuel. It's a component to a lot of things, actually. But you can just brief the portfolios of proton spin technology to understand that. So here's where we're at. We're going to be testing this in the next 24 to 48 hours. Thank you for watching, and have a good day.